Good morning, respected subject teacher and non-modular friends. Today we are here to talk about the topic numerical competition, and let's start with no further delay. So I will be talking about the basic theoretical part that comes under this topic. So first we need to learn what is numerical computation. Numerical computations are the different methods and algorithms that are used to solve a mathematical problem. So it is used in different fields like physics, engineering, weather forecasting, data science. So in this modern world, numerical computation is very important. So almost everything works under the basic principle of numerical computation. So numerical computations have different characteristics like accuracy. So let's first learn about accuracy. So a value is said to be accurate if it is more likely to be close with the true value or exact value. So if while doing numerical methods, there are different errors that can affect the accurate value of our result. So we can get the accuracy by the following formula, like where xt is the true value and xa is the approximate value. Likewise, percentage of absolute error is xt minus xa xt 100%. So let's talk about the next characteristics of numerical computation, that is rate of convergence. So rate of convergence means how quickly the calculated value is getting closer to the absolute value. So next characteristics is numerical stability. So numerical stability basically means it is a phenomenon where the true value where the where the calculated value is decreasing its error percentage. Like if the error keeps on decreasing in each step, then it is said to be numerically stable, and if the error keeps on increasing in each step, then it is said to be numerically unstable. So now let's talk about efficiency. So efficiency is how quickly and efficiently a numerical method is doing its no, it is efficiency is how quickly and efficiently a numerical method solves a mathematical problem by using least amount of resources like memory and number of integrations and so on, time and now let's talk about non-linear equation. So non-linear equations are these equations that are not linear. Basically, if in any equation the degree of the variable is said to be greater than 1, then it is said to be non-linear equation. For example, x square minus 2 equals to 0. So here the variable's power is greater than 1, so it is said to be non-linear equations. So non-linear equations are of different types, like first one is algebraic equation, 2 is polynomial equation, 3 is equations. So algebraic equations are those equations where simply we need to understand that if the function is equals to 0, then it is said to be algebraic equation. So all the algebraic functions that comes under algebraic equations are algebraic equations. So polynomial equations are those equations, those functions that are polynomial. Like if the function is equals to 0 and also it is in the degree of polynomial, then it is said to be polynomial equation. So transcendental equations, it consists of functions like logarithmic functions, exponential functions, and so on. So next topic is non-linear function, roots of non-linear functions. So that is being explained by an expert.
In this topic now we are gonna learn about the roots of non-linear equation. There are four steps, four methods of finding roots of non-linear equation. They are direct analysis method, trial and error method, and the graphical method and iteration method. And in 11 we are gonna learn about bisection method and interaction method, which falls under iteration method. In bisection method, we find the roots of a non-linear equation by dividing into sub intervals. Like at first we need to know what is the root. Root is the value of x when the function fx is equals to 0, and using bisection method we find the root of a non-linear equation. Let's suppose a function fx and its root falls under the interval a and b, and using bisection method we can find its root. And now at first we need to know that if the root falls under this interval or not. For that, according to Bolzano's theorem, we need to find f a and f b. If its product is less than 0, then we can conclude that the root falls under this interval. After finding this, now in the second step we find the midpoint of these two points, which let's suppose it at C. Then now in the third step we find FC. FC is equals to 0. Then according to the definition of a root, then the root will be C. Then the root will be C, and if FC is not equals to 0, then we need to find the interval at which the root falls in. Then we need to find fa into fc and another fb into fc. अब हाम्रो यो दुईटाबाट चाहिँ कुनै पनि 0 भन्दा सानो आयो भने देन अब यदि यो कन्डिसन चाहिँ हाम्रो यो कन्डिसन चाहिँ हाम्रो यो उसले चाहिँ कम्प्लिट गर्छ भने चाहिँ हामीले चाहिँ देन हामीले चाहिँ a लाई चाहिँ a के सपोज गरेर एन्ड c लाई चाहिँ b के सपोज गरेर फेरि यहाँबाट चाहिँ फेरि यसको मिड पोइन्ट निकालेर यसरी नै मिड पोइन्ट निकालेर अगाडि बढ्छौँ. अनि यदि हाम्रो चाहिँ यो कन्डिसन सेटिस्फाई हुन्छ भने चाहिँ यो कन्डिसन सेटिस्फाई हुन्छ भने चाहिँ हाम्रो यो गरेर चाहिँ हामीले चाहिँ फेरि यही स्टेपमा गएर अनि हाम्रो रुट निकाल्छौँ. अब हामीले चाहिँ कति बेलासम्म यो स्टेप गरिराख्ने पनि भन्ने चाहिँ हाम्रो स्टपिङ क्राइटेरिया हुन्छ बाइसेक्सन मेथडको. हाम्रो चाहिँ अब यदि एफसी इज इक्वल्स टु 0 भयो भने चाहिँ सी भनेको हाम्रो रुट हो भन्ने चाहिँ एउटा हाम्रो स्टपिङ क्राइटेरिया हुन्छ. अनि अर्को भनेको चाहिँ हाम्रो चाहिँ म्याक्सिमम नम्बर अफ इक्वेसन हुन्छ. म्याक्सिमम नम्बर अफ इक्वेसनलाई चाहिँ हामीले एन भन्छौँ. त्यो चाहिँ निकाल्ने फर्मुला चाहिँ यो चाहिँ म्याक्सिमम नम्बर अफ इक्वेसन निकाल्ने फर्मुला हो. यसमा चाहिँ यो ई भनेको चाहिँ एरर टोलरेन्स हो. अनि यो म्याक्सिमम नम्बर अफ हाम्रो क्वेसनमा दिए अनुसार म्याक्सिमम नम्बर अफ इक्वेसनसम्म गऱ्यौँ भने चाहिँ हाम्रो त्यो पछि हामीले स्टप गर्दै हुन्छ हाम्रो प्रोसेस. अनि अर्को चाहिँ हुन्छ हाम्रो यो कन्डिसन पनि हाम्रो यो कन्डिसनसम्म आयौँ भने चाहिँ हामीले हाम्रो प्रोसेस चाहिँ स्टप गर्दै हुन्छ अनि जुन हाम्रो सीको भ्याल्यु आउँछ त्यसलाई चाहिँ हामीले आफ्नो रुट मान्छौँ अनि त्यो पछि चाहिँ अर्को पनि हाम्रो हुन्छ यो कन्डिसन नै सेटिस्फाई गऱ्यो भने हामीले आफ्नो रुट चाहिँ निस्किन्छ एन्ड अनि त्यो पछि अब हाम्रो अर्को चाहिँ न्युटन ऱ्याप्सन मेथड छ अनि न्युटन ऱ्याप्सन मेथडलाई आई लाइक टु
So Newton-Raphson method. Let's start by asking a question, which is, what is Newton-Raphson method? Newton-Raphson method is a numerical method which is used to find approximate solutions of the equations which are in the form f of x is equals to 0. So in this Raphson method, we do not solve it directly. Instead, we take an initial guess first, and then by using the function and its derivative, we solve it step by step by improving our guesses. And this method is mainly used in solving nonlinear equations where normal algebraic methods are not applicable. So first I will explain it by showing it in a graph. This is a function y is equals to f of x. Now our main goal is to find the root, right? So the root is over here. In order to find this, first of all, we'll take a point x naught. Now we go up to the function and draw a tangent line from over here. Now this point where we cross it, this is going to be our new guessing point, which is x1. This is our new value of x. Now we go up again and repeat the process. Draw a tangent line again from here. Now here is x2. Now similarly we go up again, draw a tangent, and we can see that progressively as we move on, the value of x2 is converging and getting closer and closer to the root which is over here. So this is how Newton-Raphson method works. Now using this graph, we can also derive the formula using Newton-Raphson method. You all can check it in the book because we don't have time. I'll just be writing down the formula over here. So the formula is xn plus 1 is equals to xn minus f of xn by f dash xn. So in this formula, xn stands for our correct guess. Function of f of xn stands for the value of the function, and f dash xn is the derivative or slope of the function, while xn plus 1 is our improved guess. Now that we know this much about Newton-Raphson method, let's talk about where it is used. So in physics, Newton-Raphson method is used to solve equations, complex equations about motion and energy. In maths and computer science, it is used to find square root and also to solve nonlinear equation and optimization problems. It is also used in our calculator for quick and accurate computation of square root and trigonometric functions. So although Newton-Raphson method is a really powerful method, there are some limitations of it too. So if our initial guess is too far off from the root may not, it may fail to converge. And also if our derivative f dash x is equals to 0 at any point, then the method will just break down because it is not allowed to divide by 0. Now let's make our concept even clearer by solving a problem related to this method. X cubed minus x minus 4 is equals to 0. So this is the equation we have been given, and what we need to do is we need to find the root of this equation, and we have also been told that it lies somewhere between 1 and 2, and that we need to get the root correct up to 3 decimal places. So our function is x cubed minus x minus 4. The derivative of the function is 3x squared minus 1. So let's start by plugging
and 2 into this function. So f1 is equals to 1 cube minus 1 minus 4, which is minus 4, and f2 is equals to 2 cube minus 2 minus 4, which is 2. So we can see that this value is negative whereas this value is positive. So this means that their product is negative, which is minus x. So now that we know this, we can tell that our root definitely lies somewhere in between 1 comma 2. Now let's just use the formula. Our formula is x1 is equals to x naught minus f of x naught by f dash x naught. So in x naught we need to put the value of our initial guess. So let's just take just in between the value just in between 1 and 2, which is 1.5. So 1.5 minus 1.5 cube minus 1.5 minus 4 by 1.5 square into 3 minus 1. So after we solve this, we get a value close to 1.869. Now similarly for x2, x1 minus x1 by x1. If we solve this using calculator, then we'll get the value 1.7995. These are not similar, so let's just continue. x3, for x3 we get 1.79633. So we can see that it is already correct up to 2 decimal places, but we need it correct up to 3 decimal places, so we'll do this again and we get 1.79632. So these two are correct up to 3 decimal places, so we can conclude that the root of this equation is 1.796. So that was it for my part. Hope you all liked it. Thank you.